Good morning, my dear students. Today we are going to start Newton's third law of motion. Already we had discussed in detailed analysis related to Newton's first law of motion and second law of motion. As maximum number of numericals we had solved on first law of motion and second law of motion, most importantly on the second law of motion. In third law of motion also, we will be discussing the theoretical concepts and on a whole, Newton's second law and third law of motion, some numericals also we will discuss in this session. So let's begin the session. Newton's third law of motion. Newton's third law of motion. Here it states that, see how we had discussed about the statement related to the first law and second law, the same way third law statement also I am just writing here. Every action has an equal and opposite reaction. Every action has an equal and opposite reaction. 100% of the students, I am not saying it's even 99.9%. 100% students will feel very easy while learning Newton's third law of motion, and the statement they could recollect very well comparatively the other laws of motion, other two laws of motion, right? Because it's so easy to remember or recollect. You can see here, every action has an equal and opposite reaction, but there is a lot of meaning behind the statement given here. A lot of concepts are involved in a small single statement of Newton's third law of motion, right? So when we finish the three laws of motion discussion completely, we will be sharing some kind of stories related to the Newton's three laws of motion. Then you can recollect all the three laws, first law, second law, third law easily, right? Let's come back to the third law of motion statement. Every action has an equal and opposite reaction. You can see every action, this is action. It's a force. Reaction, this is also a force. Okay, so I'm writing the same thing here. Action and reaction are two forces. Or what? Two forces. Okay, now over. Equal and opposite. What is this equal and opposite? Whatever may be the force which will have both magnitude and direction. As this force is a vector quantity, it will have some magnitude as well as the direction, right? So now come back to the statement. Every action has an equal and opposite reaction. So equal in terms of magnitude. So now these two forces, a magnitude is equal and direction is opposite. I hope you got the point here. So action and reaction are two forces and those magnitudes are same and the direction is opposite. This is the simple concept of Newton's third law of motion and its introduction. Okay, I hope it's very clear till here. Every action has an equal and opposite reaction. Here action and reaction are the two forces. Both forces are having equal in magnitude. If action force is 10 Newton, the reaction force is also will be 10 Newton, right? So, and they will be in the opposite direction. Okay, what exactly meant by the opposite direction we will be discussing soon, right? Listen to me. So listen to me an example here carefully. Look at this example. So there is a wall here. So this is the wall. Okay, so it's called wall here. So I have a ball which is thrown towards the ball. You can see here, the ball is moving in this direction. It is thrown towards the ball. So at the time of striking the ball to the wall, so what happens here? There is a force exerted. By exerted means applied. Force applied on the ball. Okay. So this is what the first case I am writing here. In the first case, what happens? Force on the wall due to the ball. F suffix WB. What is F suffix WB? I am writing here. F suffix WB is force on the wall. Force on the wall due to the ball. Force on the wall due to the ball. Okay. So now definitely the ball will be rebounces. So that is the second case I am writing. So the ball will rebounce. Here I am writing it is F suffix BW. That means force on the ball due to the ball. First case what? Force on the ball due to the ball. So second case is what? In case of rebouncing, what is happening? Force is acting on the ball due to the wall. So that's what FBW, so which is called a force on the ball due to the wall. So that's what FBW, right? So according to the action and reaction, that's the most important part of the session here. Every action has an equal and opposite reaction. Here, if you imagine or assume that the first force acting on the wall is an action, then this force is called the reaction here. So this is the reaction force. So this is the action force and this will be the reaction force, right? So both are equal in magnitude and opposite in direction. For example, the first force, the 50 Newton is the force acting on the wall. So definitely the second force acting on the ball to rebound will also be 50 Newtons. I hope it's clear for you. Alright, every action has an equal and opposite direction. So that's what, every action has an equal and opposite reaction. Okay, so this is 50 Newtons and this is also 50 Newtons. What I can say here, FWB, which is equal to FBW. Both are equal in magnitude, right? But opposite in direction also you need to show, you need to represent. So that opposite in direction is represented with the symbol negative sign here. You see, FWB is equal to minus of FBW. It's an action force and it's a reaction force. Both are equal with the negative sign indicates the direction. Both are equal in magnitude and opposite in direction. Okay, clear? So this is what I'm just making it in a box. This is the, you can say like statement of Newton's third law of motion. And one more important thing here, whatever it may be a force, whether it might be an action force or the reaction force, and this force will be equal to m into v minus u by t only. You should not get confused at all here. Any force you take in the nature, so that can be written in the form of mass into acceleration. Right, F is equal to ma, which is the final expression from Newton's second law of motion, right? Isn't it? So this is the concept of Newton's third law of motion. And let's discuss some more analysis related to the Newton's third law of motion, right? I just wanted to give you the real life, a simple scenario and or the example related to the third law of motion, right? So imagine, so this is what the hand I have, okay? I'm just closing all the fingers in this way, so I can make my hand to punch somebody or to punch something, right? Look at here. So this is the wall, right, or the board. If you carefully observe the situation here, if I apply some force of 5 Newtons on the board, what happens? 5 Newtons on the board, what happens? So a small kind of damage takes place to my hand. Yes or no? Definitely it says. A simple pain will be there for this hand. when I apply 5 newtons force on this, right? When I apply 10 newtons on this board, what happens? The amount of hurt, the amount of pain for me will increase when I apply 10 newtons of force. When I apply 20 newtons of force on this board, so definitely 20 newtons of, when I apply a 20 newtons of force on this, what happens? The pain will also increase for my hand, yes or no? So definitely it's S. If I apply 50 newtons of force to this board, what happens? The board is very strong, right? If the board is very strong, what happens? When I punch the board with 50 newtons of force, what is happening here? Definitely tomorrow I'll come to you with a band-aid to this hand, yes or no? So definitely it's just because as the force acting on the board is increasing and the pain taken by me also increasing, yes or no? So definitely it is increasing. Look at here, 5 to 50 newtons, the force values are increasing which I am applying on the board. Alright, so here the pain taken by me is also increasing. At some point of time the hand will break, hand will get a lot of hurt or damage. Right, so here I am applying an action force of 5 Newton, 10 Newton, 20 Newton and 50 Newtons. I am applying an action force. Then what is the reason for the damage for this hand? What is the reason to get a pain for this hand? What's the reason behind that? Right? So the reason behind that is the reaction force. What is the reason behind that is the reaction force. The reason behind this pain is the reaction force. So carefully listen to me the concept here. The reason behind the pain for me is what? Reaction force. Okay? Clear? So this is the concept of reaction force. So here, how much is the action force I apply? The same amount of the reaction force is also acting on me. I am applying an action force on the board. Board is applying a reaction force on me. If I punch the board with a less amount of force and the less amount of force is acting on me, less pain. If I try to punch it with a more force on the board with the same amount of more force, the board is punching me back. That's the reason I'm getting hurt. Okay, clear? So this is the concept of action and reaction forces. Are you understanding? I hope you're saying yes, right? Let's move on to the Newton's third law of motion only. Okay, here I just wanted to mention 2-3 important statements here, right? So the statement number 1 is action and reaction forces. Action and reaction forces acts on 2 different bodies. Action and reaction forces acts on 2 different bodies. And most of the people think that action and reaction forces acts on the same body, right? So when we are applying the force on this board, and most of the students feel that or assume that, so everything is for this board only, either on action or reaction force, right? But it's wrong, understand? So, but it's wrong. Because when I punch the board is giving me the punch back. When I throw the ball to the wall is giving a force to the ball to bounce back. Okay, let's take example of this case. Action force is acting on which body? Action force is acting on the wall. The reaction force is acting on the ball. Understand? Action force is acting on the wall. The reaction force is acting on the ball. That's why it is bouncing back. Understand? Action and reaction are not on the same body. Look at here. Action and reaction forces acts on 2 different bodies. Remember? Okay. And number 2. It's a commonly asked question in 1 mark questions in your board exams. Which force is first, action or reaction? Which force is first, action or reaction? Listen to me carefully. 90% of the students tell that action is first, then only the reaction. Because in our daily life, imagine you have done something to your friend, right? Your friend will be waiting for the right situation and right moment to give you back. Understand? Clear? So here, it will not be the same situation here. When I give a punch of 50 newtons to the board, this board will not wait for the time and the moment to punch me back. Understand? So at the same instant, it is giving me the punch. That's the reason. So I got hurt here. Okay. When I apply 50 newtons of force on this board, so the board will never wait for a next day. So next day, this sir will come. Then I can give the punch back. It will not think like that, right? So when I give the 50 newtons force on the board, at the particular instant, at the same instant, what happens? So there is a 50 newton force is acting on my hand here. Clear? That's the reason behind this pain. Understand? So action and reaction forces occurs at the same time. You can say simultaneously action and reaction forces acts. So I'm writing the same here. Action and reaction forces. Action and reaction forces acts simultaneously. Simultaneously it acts. Simultaneously on how many bodies? On one body or two bodies? On two different bodies, right? So these are the two important statements. Even when you finish your studies, when you go for any interview, being a physics student, right? This is the commonly asked questions by the interview board, right? So in the interview board, the people will be sitting there. As you are a physics student or a science student, the probability of asking the questions from Newton's laws of motion is more. Okay, so be ready, and this is what the basic questions asked. Right? Action and reaction forces act on two different bodies. Action and reaction forces act simultaneously, right? Same time. So don't think that action is first, then the reaction comes into the picture. Okay, now, and one more important point I just wanted to tell you here. The forces always exert in pairs. Okay, so you cannot see a single force in this case. When there is an action, definitely reaction force will be there. Okay, when there is an action, reaction force must be there. Okay, now let's see few more examples related to the Newton's third law of motion. Few more examples related to that, right? So I'm just giving you the examples here. So what you can say, the first one is recoil of a gun. A recoil of a gun. And the rocket propulsion. Rocket propulsion is also an example of Newton's third law of motion. And you can say the rowing of a boat, or rowing a boat is an example of Newton's third law of motion. And here, bouncing back of a ball, right? A bouncing back of a ball. So this is the that's working on the floor. That also comes under Newton's third law of motion, right? So wherever action and reaction is taking place, you can say that's an example of Newton's third law of motion. And let's look at here a recoil of a gun. One by one we will discuss. It will not take much time. Okay. So anyhow, I know, as I've seen so many students so far in these 10 years of period, right? So majority of the students, the Newton's third law, they tell me that Newton's third law is their favorite laws of motion because it's easy and interesting, right? But in the similar way of easy and interesting way, we had discussed our Newton's first law of motion and second law of motion. I hope you could recollect first law of motion and second law of motion at this time. Okay, now one by one we will discuss recoil of a gun. You know what exactly meant by the recoil of a gun? About the recoil of a gun and the rocket propulsion, we will be discussing in detail soon. Okay, so right now, recoil of a gun. Imagine, so this is what the gun. So I have told you, don't think that it's a pipe. So first time being, you just imagine that it's a gun. So when we fire the bullet will come in this direction, right? Imagine a bullet direction, action force is applied. So there is an action force is applied in the bullet direction, this action force, right? So what happens, due to the reaction force? So when the bullet is moving forward, there is a reaction force is acting on the gun. Okay, first what happens? There are two bodies here, so gun and the bullet. Action force is acting on the bullet. What I told you, on the bullet. So definitely reaction force must be acting on the gun, right? So due to this action force, bullet is moving forward. So definitely due to the reaction force, gun will move backward. Yes or no? I hope you got the point. Action force and reaction force. Because of the action force, the bullet is moving forward, and because of the reaction force, definitely gun will move backward here. So that backward movement of the gun is called recoil of a gun. What is that? Recoil of a gun. It's due to the action-reaction pair only. Okay. Now the second one is rocket propulsion. In rocket propulsion, look at there, in rocket propulsion, imagine it's a rocket. Rocket, see. So, the principle behind the rocket propulsion is Newton's third law of motion only. See, to look, the Newton's third law of motion is so simple and so short and sweet definition and the examples, right? The application of it. Application of it is the rocket propulsion. The prestigious part of the countries is related to the space, right? So related to the rocket technology. Okay, so in that rocket technology, Newton's third law of motion is used. Let's see here. So inside the rocket, there is a fuel which will be burnt during the motion of the rocket. So when the fuel is burnt in the rocket, so what happened? It comes out as the gases. Okay, so these are called burnt gases. Burnt gases will come out of the rocket with some force on them. Understand? So force acting on the burnt gases. That's the reason they are coming out of the rocket. So this is what the action force. Action force is acting on the gases. So because of the action forces acting on the gases, gases will eject the rocket, and due to the reaction force, the rocket moves in this direction. This is the movement of the rocket due to the reaction force. Due to what? Reaction force. Is it clear? Clear. So if this is action force and reaction force is like that, and here also recoil velocity of a gun is also similar concept. And this is how Newton's third law of motion we can discuss. And you can see the rowing of a boat. When we apply a force on the water in this direction, water will apply a reaction force on the boat. Okay, we are applying force on the water, water will apply force on the boat. Okay, so the conditions are satisfied here. Action and reaction forces acts on two different bodies. We are applying force on the water, water is applying force on the boat. Okay, and here action and reaction forces act simultaneously at the same time. Okay, so now you applied some force on the water, water will not wait for some time to apply force back. At the same instant, simultaneously, both action and reaction forces takes place. How fast or how higher the magnitude of the force acting on the water with the same amount of magnitude of force will be acting on the boat to move forward. Understand? So this is what Newton's third law of motion and examples of them. Now look at here, my dear students. We'll solve some problems related to the second law of motion and third law of motion. Why second law of motion and third law of motion? Whatever it may be, the force is equal to m into a, which is m into v minus u by t. That's what I told you, right? Now, a bullet is fired from the gun experiences a force of 600 minus 2 into 10 raised to 5 into t. Okay, so the given force is equal to 600 minus 2 into 10 raised to 5 into t. So by looking at the problem or the given data, you should not be afraid. Just try to finish the reading of the problem first. In the barrel of the gun, okay, here t is in seconds. This is the t is in seconds. That means it's a time. The force becomes zero as soon as the bullet leaves the barrel of the gun. So this is the force value is becoming zero as soon as the bullet leaves the barrel. When this force is zero, so I can write 600 minus 2 into 10 raised to 5 into t is equal to 0. So then what I can write here, 600 is equal to 2 into 10 raised to 5 into t. Now the question is, the time for which the bullet was in the barrel of the gun. So this is the time for which the bullet was in the barrel of the gun. So this is the time they are asking. So simple. Our aim is to find this time t. How simple it is? Here, this is the equation. I can write it as 600 is equal to 2 into 10 raised to 3 into 100 t. Can I write like that? So because 10 raised to 3 into 100 is 10 raised to 5 only, right? 2 zeros and 2 zeros cancel. It is 2 3s. So what is remain here? 3 is equal to 10 raised to 3 into t. So what is this t here? T is equal to 3 by 10 raised to 3 seconds. Alright? So the options they will be giving you like this. 3 into 10 raised to minus 3 seconds. And look at this answer. Like this questions can be solved. You know. And let me tell you one important thing which you will not believe at all. This is the question. Will also repeat in your first PUC chapter called Laws of Motion. And this was the question asked in one of the AIPMT exam. So AIPMT exam was conducted and before the NEET concept has arrived. Understand? When there was no NEET, the All India level exam for the medical entrance purposes was AIPMT. Okay, so in that AIPMT exam, this question was asked. So just 6-7 years before, right? So similar to your NEET exam only. So this question was asked, right? Now, in a rocket, the fuel burns at the rate of 2 kg per second, right? So the mass of the fuel is how much here? So mass of the fuel is 2 kg and a given time is equal to 1 second. So you can see per second. This fuel gets ejected from the rocket with a velocity of 20 kilometers per second. You know the concept behind that. Understand? So rocket propulsion. Newton's third law is the base, right? So it is moving. The fuel is moving with a velocity of 80 kilometers per second, and if you carefully observe, here it is kilogram, it's a SI unit, and here it is kilometer, it's not SI unit, right? So this can be written as meters, 80 into kilometer, so that is 10 raised to 3 meters per second. Okay, so velocity also we have got. Find the force exerted on the rocket. Force exerted on the rocket which is equal to force exerted on the gas. Yes or no? See? As action force is equal to a reaction force according to the third law of motion. So what I can write here, carefully go through that. F is equal to ma, which is equal to m into v minus u by t. Okay, so this is what they have given about the data they have given about the gases. Okay, so the mass of the gas is given, with what velocity the fuel, the gas is coming out of the rocket is given. So that's the reason this complete concept of force is related to the gases here. So So this F is equal to M. M is mass of the gas, it's given. V is the final velocity of gas, it's given. And U is the initial velocity of the gas. Here comes the two important divisions here. So the complete scenario of rocket propulsion or recoil velocity of a gun can be divided into two parts. And number one is, for example, rocket propulsion case. Number one, first case is before firing and second case is after firing. In the same way, recoil velocity also before firing and the after firing. In rocket propulsion case, before firing, initial velocity of the rocket is 0, initial velocity of the fuel is also 0. Whereas in recoil velocity of a gun also, before firing, the gun velocity and the bullet velocity is 0. Rocket propulsion, before firing, rocket velocity and the gases in the rocket velocity is 0, because they are not moving in the first cases, right? So here what I can write, initial velocity of the gas is also 0 meters per second. Just substitute everything. F is equal to mass is 2 kg into final velocity, it's 80 into 10 raised to 3 minus initial velocity 0 divided by time. Time is 1 second here. So F is equal to, it's 2 into 80, it's 160 or 16 into 10 into 10 raised to 3. So what is the total I can write? 16 into 10 raised to 4 Newton, as we are discussing about a force. As our aim is to find about a force, we have got F is equal to 16 into 10 raised to 4 newtons, like this. So many numericals we can find, we can solve based on Newton's first law of motion, second law of motion and third law of motion. So my dear students, let's continue two more problems related to the Newton's second law of motion and third law of motion. Let's see. A machine gun fires a bullet of mass 40 grams. Grams is a CGS unit of the mass. Okay. With the velocity of 1200 meter per second. 1200 meters per second. It's a SI unit. Meter per second. It's a unit of velocity. The man holding it exert a maximum force of 144 Newton on the gun. The number of bullets he can fire per second. So the question is number of bullets he can fire per second. Okay, what is the data given? Let's write first and you can understand what was the formula to be used. Number one, machine gun fires a bullet of mass. Mass is given as 40 grams and we had observed just now all the other data are related to the SI units of the physical quantities. But only the mass is given as CGS unit. So we can convert it into the SI unit. 40 into 1 gram is 10 raised to minus 3 kilogram. Now, directly I can write 40 by 1000. We can write 0.04. But I'm just writing it as like this. Now, velocity is 1200 meters per second. It's 1200 meters per second and it's a final velocity of the bullet. Okay, because before firing, initial velocity of the bullet will be 0. So that we have just now discussed, is it 0? Then the man holding it can exert a maximum force of 144 Newton is the force. The number of bullets we need to find out and the given time is equal to 1 second. Okay, what is the formula can be used here? We can use the formula F is equal to M into V minus U by T. Okay, so that's a force acting on a single bullet is F is equal to M into V minus U by T. But there are n number of bullets, they said. So into n, this is the application we had already discussed. Okay, so here you substitute everything. F is equal to, F is itself given as 144 Newton. 144 is equal to mass. Mass is given as 40 by 1000 into V minus U. What is V here? So 1200 minus U is 0 divided by time is 1 into number of bullets N. Alright? So 1, 2, 3, 1, 2, 3, cancel. Okay, so what is remained here? It's 144 is equal to 4 into 12 into N. So 4 into 12 into N. So this is 12. 12s are 144. Clear? So 12 is equal to 4 into N. 4 threes. See how many bullets he can fire per second. So 3 bullets the person can fire per second. Okay. So this is how this is the commonly asked question as a basics of your 11th standard, right? And look at this question. And this is the question in one of the JEE exams, not even KCET. In one of the JEE exams, this question was asked. Let's read the question. A particle of mass 0.3 kg is subjected to a force of F is equal to kx. Alright. With K is 15 Newton per meter. See, what is this K and what is this X? This doesn't matter to you now. There is a separate meaning for this K and X that you will be learning in the first PUC or in the second PUC. But we need to focus on the force which is equal to mass into acceleration. So believe in your formula called a force is equal to mass into acceleration. Whatever may be the other expressions is given in the numerical, just equate with this force. For example, here F is equal to Kx, right? So that Kx is equal to your Ma. If F is equal to Bx, that Bx is equal to your Ma. If F is equal to Ax, so that your force Ax is equal to Ma. No problem at all. Understand? Now, because they given X, see, K is a constant. This K is constant. Your M is also a constant. Right? Now, and X being the distance from the origin, and X is the distance from the origin. What will be its initial acceleration? We need to find the acceleration. If it is released from a point 20 centimeters away from the origin, 20 centimeters is the X value. Let's write down whatever the values they have given. So they have given mass is equal to 0.3 kilogram, F is equal to Kx, K is equal to 15 Newton per minute. And what will be the acceleration? Acceleration we need to find out. When the point is 20 centimeters from the origin, 20 centimeters I can write 20 into 10 raised to minus 2 meter. Now, the question is to find that acceleration. We know F is equal to Ma, we also know F is equal to Kx. I can write this F is equal to Kx, which is equal to Ma, because F is equal to Ma. From this, what I can write, your A acceleration value is K into X by M. Just substitute K, X, M, you get the answer. So what is K? Acceleration is K, 15 into X. X is how much? So 20 by 100 into, right? So this is 20 by 100 into, so what is M? M is 0.3. M is what? 0.3 here. So here 1 0 1 0 cut, and this 0 and this point will come here, it will be 3, and denominator it is 3 and the numerator is 15 into 2. So 15 into 2 by 3. Okay, so this is 3 5s. So acceleration is equal to 10 meter per second square. Is it okay? Clear? Like this kind of questions will be asked in the JEE question. See, we have discussed no need of knowing about what is the requirement of knowing about K and X here. There's no need, right? So the simply whatever the force expression is given, you need to equate to your known force expression. F is equal to Ma, so that you can solve like this, right? So we'll be solving a more number of numericals in the next session, and more stories related to Newton's first law, second law and third law of motion. Right? So thank you so much. See you soon.